Okay, hello guys. Today we are talking about the graphical relationships. Okay, so let's move to the first part about how is a reflection property. Okay, so here we knew that for y equals to fx reverse. So here the -1 means that a reflection of the graph with the line y equals to x. Okay, so you can just consider here. Sorry. Okay, so if here we have a coordinate and we have a graph like this way. And we can say that we can draw a line y equals to x, like the blue lines. And then we can then draw a line of the reflection like this. Okay. So we can say here, right now, parabol curve is reflected by y equals to x line to the blue curve. Okay. So that we can say that if this is a original function fx, and this is can be considered as a fx inverse function, okay? So that is the basic geometrical properties of this. You don't need to understand y's for geometrical reflection. Okay, so you can just understand here for x, y, and this point is for y-x. So their perpendicular dissector if y equals to x between the 2 points and they form a sector, and they form a very small segment. Okay, so here we can just consider like this way, okay? But that obeys the rules for reflection property, okay? Okay, so we can also visualize the reflection like if fx across the x-axis at a or a0, we can set the fx inverse function across the y-axis at 0, a, okay? That is how we can consider that. So we can just try to draw the graph like this way, okay? So first it crosses the x-axis with a, and then it crosses the y-axis at A, like here. That is a reflected, right? You can find that the x coordinate and the y coordinate swap together, okay? And also because there's a self-inverse function. That means after it inversed, it also equals to itself. So for example, like fx equals to x or fx equals to negative x, they obey the rule that their reflection after y equals to x still equals to themselves, okay? So also the example like here, fx equals to 1 over x, and fx equals to x plus 1 over x minus 1, okay? That is the 4 examples here, and you can just try to draw the graph, and you can find the principle and the result, okay? So if we have a question like solving the fx equals to fx inverse function, so you can just try to first draw the graph of here, okay? So because we knew that maybe for fx and f inverse function that they're like reflected to the y equals to x, but that means that their lines, sorry, the lines here and the two curves just have the same intercept. So this value equals to find the solution of fx equals to x, okay? Because that is y equals to x. Maybe here is for fx, here is for f inverse x. So they just have the same intercept, okay? That is how we can understand for this. Okay, so maybe after the class, I hope you can just try to solve some problems. Maybe I'll give you an example like here, okay? So if you want to solve the function for the y equals to x squared plus 4x minus 2, if you want to calculate the equation like fx equals to f inverse function, so right here, maybe it's very hard for you to calculate it, right? So now you can just use it as equals to x and to find x squared plus 3x minus 2 equals to 0. So then you can find that, oh, maybe here x equals to, here's for 2a, here's for negative b plus negative b squared minus 4ac, right? So that you can put the value into it is 2, here's for negative 3 plus negative, here's b squared is 9, and minus 4 times a times c is minus 4 times 1 times negative 2, right? So it is plus a. So the value here is for negative 3 plus or negative square root 17, okay? That is the exact value here and help you can find the exact solutions or exact rules here, okay? So that's for this our lesson. Hope you can understand it for this. So see you next time. Bye.